Part 5, Door Performance and Construction. 60. Timber door constructions. Timber door leaves are typically constructed with a door skin that can either be painted or have a wood veneered finish, underneath which there is a door core, sometimes including framing and hardwood lipping. The choice of core can have a significant impact on their performance and durability. The four main generic types of core are: middle dot timber framed flaxboard core, middle dot laminated timber core, middle dot graduated density core, GDC chipboard, middle dot tubular particle core. 61. Correct specification of fire door. The specification and choice of core will be key to whether door leaves are suitable for medium to heavy duty usage and impact, or are only suitable for light duty use, such as being fitted to a riser cupboard and only being opened on an infrequent basis. 62. Required antibacterial and impact protection. In addition to painted and veneered finishes, fire doors in acute environments are often wrapped in sheeting and provided with special safeguards offering antibacterial and impact protection. 63. Timber door frames. Timber door frames should not be accepted if they are less than 30 mm thick for FD30 doors and 44 mm thick, hardwood, for FD60 doors unless accompanied by evidence of performance. MDF door frames should be treated with caution as they can have poor impact performance and longevity. Oversized doorstops are no longer required for door leaves with edges fitted with intumescent strips. A 12 mm planted stop fixed with nails is acceptable. A wooden door leaf in a steel door frame must have been tested together as they behave differently in a fire, wood shrinks and steel expands. 64. Steel doors. Steel doors are normally factory assembled or provided in a complete kit for on-site assembly, which should ensure they will meet the specified and required fire performance. They are normally constructed of 1.2 mm or 1.5 mm zinc-coated steel sheet and paint finished, with various infills to meet specified fire and acoustic requirements. They are normally integrity only and thus do not have to meet a heat transfer insulation requirement. They can offer fire integrity of up to 4 hours and are often specified where high fire ratings are required. They do not normally require intumescent strips as they expand and wedge into the frame when exposed to heat, but will require cold smoke seals in locations where there is a need to contain smoke. 65. Door furniture inspections. Door furniture inspections should include checks on: hinges are screwed tightly to door and frame. The number and size of hinges is as required in the evidence of performance. Locks and latching mechanisms are functioning correctly. Door closers are securely fixed and are functioning correctly. Any damage, bows or bends do not prevent the door from functioning correctly as a fire door. The smoke seals are in contact with the door between leaf and frame around the head and both sides. Gaps between back of frame and substrate are adequately sealed. 66. Steel doors are unforgiving. Steel doors normally factory assembled are unforgiving in terms of fire integrity, and should be checked and assessed for defects and damage. 67. Glazed fire door sets. As with steel doors, glazed fire door sets are normally factory assembled and installed by the manufacturer or specialist installers as a complete door set. Evidence of performance is key. Glazed fire door sets are often first and foremost about the specification of the glass and then the adequacy of the frame to hold the glass in the event of fire. They can be manufactured to meet the requirements of integrity, insulation and heat resistance, but many existing systems are integrity only and are not easy to manage and maintain. 68. Gaps and seals. There are two generic types of material used in intumescent seals: sodium silicate, which expands between 100 C and 120 C, and graphite, which can expand at various temperatures between 170 C and 300 C depending on the manufacturer and their cake mix recipe. Because of the big potential temperature variance of when they intumesce, different products should not be mixed and matched around the door perimeter. 69. Primary function of intumescent seals. The primary function of an intumescent seal is to expand, intumesce, when exposed to high temperatures, sealing the gaps between the door leaf and frame and between leaves in a double door set. 70. Smoke and intumescent seals. Smoke and intumescent seals can be separate but are often combined, with the smoke seal being provided by a brush or fin. Fins provide less friction and are seen as the best option to meet compliance with Part M of the building regulations. 71. Fins v brushes pros and cons. Fin seal pros. Low opening forces, good for Part M compliance. Easy to clean. Allow continuous sealing around ironmongery. Fin seal cons. Flexibility of blade and poor impact resistance reduces durability, often resulting in early fracturing, leading to higher frequency of inspection and maintenance costs. Flailing fractured blades can compromise self-closing. Not suited to new doors in old frames or retrofitting due to likelihood of variable gaps. Brush seal pros. Robust with good impact resistance and long service life. Available in BS 476 to 31.1 tested variants for larger gaps, up to 7 mm. Care needs to be taken how this is justified. Low maintenance. Brush seal cons. Higher opening forces. Brush seals not bonded into the carrier frequently suffer from seal creep, where the brush slides out of the carrier, which can lead to self-closing issues. Item of note, Lorion bond their brushes into their carriers, though never a problem. FD30, seals interrupted by ironmongery. 72. Harm arising from smoke inhalation. When considering smoke seals around doors, it should be borne in mind that in a typical year approximately 60% of fatalities through fire are actually due to smoke inhalation. Old statistics but still relevant and show the harm that can arise from smoke inhalation. In 2017-18 there were 334 fire-related fatalities in England, with 99 arising from gas and smoke, 50 from burns, gas and smoke, and 92 that were unspecified. 73. Toxic gases and carbon monoxide. Smoke creates a lethal atmosphere containing carbon monoxide and other toxic gases, so it is generally recognized that the main function of fire doors in a fire incident can be to prevent the unchecked spread of smoke. Clearly, the gaps and seals around the perimeter edge of a door are critical as to how effectively the fire door will function when required. Cold or ambient smoke seals help to protect adjacent compartments in a building from the passage of toxic smoke as it travels from the fire origin, and can be critical in some locations such as refuge areas and evacuation corridors. 74. Seal do's and don'ts. Do. Ensure seals comply with manufacturer's test evidence. This will mean that only seals manufactured under UKAS-accredited third-party schemes should be used. Ensue door leaf-to-frame gaps are 3 mm/+1 mm. This is the typical gap allowed for a fire door to function and which manufacturers use in seal arrangements for both cold or ambient smoke leakage performance and intumescent seals in fire tests. Ensure smoke seals come into contact with the door edge if fitted in the frame, with the frame if fitted to the leaf, and create a cold smoke seal at the meeting edge in double leaf doors. Interrupting a smoke seal at hinges or other ironmongery positions can seriously reduce its effectiveness and may not be how they were tested. Ensure threshold gaps are to a 0.10 mm maximum for fire doors, 0.3 mm maximum, with a 1 mm tolerance, for a fire and smoke door. These should be labeled with a suffix as in FD30S. Don't mix and match smoke seals around the perimeter of a door, as they are likely to intumesce at different temperatures. Different types of seals should not be substituted. 76. Intumescent seals and gaskets. Intumescent seals and gaskets are found in various parts of a modern fire door and are often integral to them passing their fire tests. Any aperture which is cut into the fire door, irrespective of its size, will need some form of additional intumescent protection to maintain the fire door's integrity and designed performance, so whether it is a door viewer or letter plate being fitted. Currently there are two fire test standards in the UK, BS 476 and EN 1634. This enables door manufacturers to choose which fire test they wish to undertake. The ironmongery manufacturers have no choice. To achieve their performance standards, they have to undertake the European fire test, for example EN 1935 for hinges, and then gain the CE mark, to prove the product's suitability to be fitted on a fire door. As the N test is more onerous than the original BS test, with furnace temperatures reached much more quickly, some of the essential ironmongery may need additional intumescent protection. Monoammonium phosphate is not an expanding intumescent but acts as an insulator, ensuring that there is no integrity failure on either the fire door or frame from, say, the hinge blades. The material comes in 1 mm or 2 mm, and it may mean 1 mm under each hinge blade on an FD30 and 2 mm on an FD60. Each essential component will have its own test evidence detailing exactly what additional intumescent protection is needed and how it is to be fitted. If a door set is being supplied, then if needed it will be fitted with compatible and tested intumescent seals, but the biggest area of nonconformity is when contractors bring the components together from separate sources. If intumescent material is needed and not fitted, then in the event of a loss of life the manufacturers will not accept any liability as their test evidence was not followed. 77. Fire door viewers and letter plates. Intumescent seals, as tested, should be used for fire door viewers and letter plates. 78. Fire and smoke integrity for air transfer grills. To ensure the fire and smoke integrity of air transfer grills, intumescent seals should be fitted to air transfer grills. Where there is a requirement purely to resist the passage of fire, a tested internal grill made up of intumescent heat-activated strips is acceptable. As intumescent seal only reacts when exposed to high temperatures, where a fire door is fitted to provide fire and cold smoke capability, such as on an escape route, then an electromechanical seal, activated by a smoke detector or alarm panel, is required. 79. Fire sealing gaps between the rear of the frame and the wall. Any gaps between the rear of the frame and the wall must be fire sealed using a fire-tested fire joint design with evidence of performance, for example correct depth to width ratio, which for intumescent mastics tends to be 1:1, i.e. if you have a 20 mm gap you will need a 20 mm depth. An alternative is to follow guidance in BS 8214-2016. The use of foam should be treated with caution and should only be accepted if there is evidence of performance. 80. Vision panels. Glazing can be an essential element in providing vision so that people can be made aware of other people or obstacles on the other side of the door, thus reducing the risk of accidents, but it can also be used for aesthetic reasons as well as providing natural lighting and opening up areas to accentuate space. On new door installations there is a requirement to comply with Part M of the building regulations to provide vision for wheelchair users. This includes having vision panels at least 500 mm above floor level to a height of at least 1.5 m. 81. Matching fire rating of glazing to doors. The most important characteristic of glazing in a fire door is that it should match the correct rating of the door and not reduce the fire capability. For this reason, the whole door set needs to be tested as a complete entity. There is commonly a lack of appreciation that fire-resistant glass must only be used as part of a fully tested glazing system, including seals, beads and associated fixings that allow for expansion and movement in a fire. 82. Fire door glazing with incorrect seals. We have already explained how fire doors are tested and that various components in a door can create a weak spot and point of failure. Within the presentation is a video clip shared with kind permission of Lorion, which shows what can happen in a fire test if fire door glazing does not have the correct seals. 83. Glass in doors and screens. Glass in doors and screens must also comply with minimum impact safety requirements. Glass should be marked to advise its rating, typically 30 or 60 minutes tested to BS 476-22 or the European BS N 1634-1. BS 6206 Orbson 12600 refers to impact resistance only and may not have a fire rating. Georgian wired glass is often assumed to have a 30-minute integrity rating, but that may not always be the case. Standard glass has no significant fire rating. It should be noted that standard fire-rated glass offers an integrity rating only, which prevents the fire from physically passing through, but does not prevent the transfer of heat. Where heat transfer is a potential issue, such as a refuge area or escape corridor, the glass will need to be upgraded to provide heat transfer insulation. 84. Glazing hardware. Certain hardware items are essential to a door's function as a fire door. There are different generic types, and choice may be governed by the type and requirements of the door. It is recommended. Middle. All doors on main traffic and circulation routes, corridors, lobbies or stair enclosures be provided with fire-resistant vision panels. Middle. Doors to laboratories, kitchens and areas where hazardous items pass through the doors regularly are provided with vision panels to reduce the possibility of accidents. Exceptions to providing vision panels are allowed where there is a need for privacy, dignity such as dubseas and sleeping accommodation. 85. Hinges. On new installations, hinges must be CE, UKCA, marked to BSN 1935. The role of hinges on a fire door is to bear the weight of the door leaf in the frame, allow the door to swing freely, be robust enough for the usage of the door, prevent the door from bowing out of the frame when under attack from a fire, which is why it is expected to have a minimum of 3 hinges, inhibit the transfer of heat from one side of the door to the other. Unless test evidence says otherwise, this will normally require no part of the hinge to extend across the thickness of a 44 mm door closer than 12 mm from the non-pivoting face and 18 mm for a 54 mm door. 86. Intumescent protection. Intumescent protection should conform to fire test standard requirements for intumescent protection behind the hinges. This is to combat excessive heat transfer and premature failure. Reference should also be made to the manufacturer in terms of what types and ratings of hinge shims, packers, are permitted. 87. Position of hinges. The configuration and position of hinges will be specified in fire test data. Doors manufactured as a door set will typically have the middle hinge fitted above the midpoint of the door to support the top hinge in carrying the weight of the door. Rising butt hinges are not suitable for use as a self-closing device due to their inability to close and latch the door from any angle and the need to remove material from the top of the door. 88. Wall-bearing hinge and bush-bearing hinge. Wall-bearing hinges are more common and less expensive. The more expensive bush-bearing hinges last longer and may be the best option for high-usage doors. They also tend to provide less friction and will help a door to meet the low opening force requirements to comply with Part M. 89. Continuous hinges in secure accommodation environments. There may be a requirement for continuous hinges in secure accommodation environments where self-harm is a risk and anti-ligature hardware is specified. 90. Floor spring door closers. Floor spring door closers are a means of both supporting and closing a door, coming in 2 generic types for timber fire doors. Offset pivoted floor springs are fitted to rebated fire doors, and center pivoted floor springs are used for double-acting fire doors, although they can be fitted in single-swing use in certain circumstances. Fire door pivots, sometimes referred to as floor springs, combine the function of hinges by supporting the door, and closing devices by closing the door. They allow the door to swing in either direction, which is often a function and requirement of some fire doors, especially cross-corridor doors. 91. Role of door closers. The role of a door close control on a fire door is to reliably close the door leaf tight against the stop from any angle to which it has been opened, overcome the resistance of any fitted latch or seals, provide easy access to people using the door, in compliance with Part M of the building regulations. 92. Door closer types. There are 2 main generic types. Rack and pinion, the most common and least expensive but tend not to operate as efficiently as cam action, which has less moving parts, therefore less friction and often better for Part M compliance. 93. Door closers available with a hold open function. There are door closers available with a hold open function and that can interface with fire alarms to automatically close in an emergency situation. N1155 is the European standard for hold open devices and the one they are normally tested to. 94. Concealed door closers. The fitting of concealed door closers can create issues with gaps and seals, and because they take away the door core, they may need an intumescent membrane to reinstate fire performance. Test evidence or a valid assessment for their use in a particular door set should be obtained. There are 3 types of concealed door closing devices fitted to timber fire doors. Installed in the top of the door leaf. Installed above the door in the frame head or transom. installed in the hinged edge of the door. These closers must have a controlled closing feature to ensure that fire doors latch. Ideally, the fire doors and frames should be mortised accurately under factory-controlled conditions to ensure that a minimum amount of door material is removed. Concealed closers should only be installed when permitted under the fire door manufacturer's instructions and in accordance with the closer manufacturer's fitting and operating instructions. Intumescent material to protect the door from early integrity failure must be fitted as instructed by the closer manufacturer. 95. Internal doors. There is some confusion regarding the use of door closers for internal doors in flats. The Local Government Association publication Fire Safety in Purpose-Built Blocks of Flats states, self-closing devices for internal doors within flats are not now required for compliance with current building regulations. Accordingly, under most circumstances, they are no longer necessary within existing flats. Other exceptions as stated in ADB are fire doors to cupboards and to service ducts which are normally kept locked shut. 96. Automatic door release controls. With the exception of doors to stairways, it may be acceptable for fire doors to be held open on electrically operated door release mechanisms provided that all of the following criteria can be satisfied. The door release mechanism should conform to BS 5839-3/1988 and BS 7273-4/2007 and be failsafe, that is, in the event of a fault or loss of power, the release mechanism should be triggered automatically. All doors fitted with automatic door releases should be linked to the fire detection and alarm system, triggered by automatic fire detectors, manual fire alarm call points, or any fault in the fire warning system including loss of power. Automatic door releases must be provided with a ready means of manual operation from a position at the door. 97. Closing speeds on doors held by electronic solenoid devices. The closing speeds on doors held back by electronic solenoid devices needs particular attention as they are typically designed to release on alarm activation or loss of power, and their sudden release could be a safety risk if there is a violent closing speed. It is good practice to release them at night, not only to close fire compartments but also to release the tension on the door leaves, which are liable to warping if permanently held under tension at either top or bottom. 98. British Standard Closing Speeds. Industry and British Standard closing speeds are flexible to allow a closing speed that is suitable for its location. Without any instructions being given, the closing speed for new doors will typically be set at 7 to 10 seconds. 99. Door coordinating devices, door selectors. Door coordinating devices, also known as door selectors, are fitted to ensure that pairs of rebated fire doors fitted with door closing devices close in the correct sequence. 100. Locks and latches. All locks, and indeed all hardware, are required to be fire tested and be compatible with the door's fire test evidence. The retrofitting of digilocks and other types of locks can compromise fire test compatibility. Intumescent material may be required between the lock and the door leaf to reinstate fire performance. The information on the slide demonstrates the complexity that can be involved in selecting hardware. N12209 applies only to single-point mechanical locks. N1303 is not a harmonized standard and there is no legal requirement to comply. N1906 is not a harmonized standard and there is no legal requirement to comply. CE, UCA, marking to N179 and N1125 does not necessarily imply that the product has been fire tested. N14846 allows CE, UKCA, marking of electromechanically operated locks and strikes. 101. Intumescent protection to ironmongery should be provided in accordance with test data. 102. Signage. All fire door signage should comply with BS 5499-10, 2014. Appropriate signage for location is determined by fire door location, use and whether it is being controlled by a hold-open device. Those to be closed when not in use should state fire door keep shut. Those to be kept locked when not in use should state fire door keep locked shut. Those held open by a device should state automatic fire door keep clear, etc.